Hello, Precalculus student. This video is for chapter 4.1, part 2. We're trying to find an exponential function if we have 2 points. So far, we haven't grabbed an exponential function, but you can kind of imagine if it's growing so fast, multiplying by constant number, it would shoot up, right? And if it's decreasing, in general, it would be like going decreasing really quickly and then gradually decrease slowly like that. So if I have 2 points, can I find an exponential function? So no, the form of an exponential function is y equal to a times b to the power x. B is the multiplicative factor or the growth factor or decay factor. A is the initial value. So here I have 2.03, 2.5, 18. So it's growing. At 2.5, it hit 18. Is it 2.5? Yeah, 2.5. So we know this is initial because x is 0, right? So if y equal to abx, so I can plug it in. Y, this is x, this is y. So my first equation is 3 is equal to a b to the 0. You can see any number p to the 0 is 1, right? So I have 3 equal to a. So I solved a already. So this is the initial value. And then, so this is the first equation. From the second point, I have another xy. So I plug y equal to a. I don't know a. I don't know b, 2.5. But I do know a. So a is 3. So I plug it in. 18 equal to 3 times b to the 2.5, right? So I divided by 3, so 6 is equal to b to the 2.5. This is actually a polynomial function. To solve it, I can take root of 2.5. We seldom do that, but you can actually do it. So b is 2.5 root. Technically, it's not supposed to be written in this way, but I guess you can. So we can do 6 to the power root of 2.5 in the scientific calculator you can do. So do 2.5 and do a root sign and then do a 6. So that would be 2.0477 if I want 4 decimal places. So the function itself actually would be y equal to 3, which is a 2.0477 to the power x. So that is the function that can model this. So you notice that b is 2.0477. That means it's growing more than 100%, right? R is more than 100%. Minus 1 is R. And then multiplicative factor is every time you multiply 2 point something, starting from 3. The second one, finding exponential function, they don't give you a graph. So is it growing? Yes, it's growing. When x is 0, you have initial value of 4 because it's 0, right? When x is 2 is 36. So we'll write the equation y, so x, y equal to a, b, x, so 0. So this is 1. So 4 equal to a. So we get the first one. And we actually solve for a. The second, it would be 36 equal to ab2, right? ab squared. But I know a equal to 4, so I plug it in. 36 equal to 4 times b squared divided by 4 divided by 4. It's just you end up having a polynomial. B squared equal to 9. Oh, and this is actually a perfect square. So square root, I don't need to do plus and minus because b is positive. Square root 9. B equal to 3. So my equation is y equal to 4, which is a. abx is 4. And then 3 to the x. And you notice that if you plug 2 in, it's 36. So these are the good number kind of function. These are more, they're not good numbers, so you have to solve for it. So, and also you don't have 0. So that means you don't know what a is. But so we'll just have one equation, xy. 5 is equal to a b to the power negative 2. Now, what is negative 2? That means 5 equal to a over b squared. Negative exponent means dividing, right? Means dividing, means reciprocal of the base. So I want to solve for A. You always want to solve for A. So if A is, the initial, you already get the number in the last one. But this one, we would just times B squared on both sides to get rid of it. So you have A. So 5B squared equal to A. So from the first one, you always solve for A. And then you use this to plug in the second one. So second one, I still have xy. 1 equal to AB squared. But I know A is 5B squared. So 5B squared times B squared. So B squared times B squared is B to the fourth. 5B to the fourth equal to 1. So how do I solve it? Divided by 5, divided by 5. Isolate this unknown. So 1/5 equal to B to the fourth. What is B? Fourth root. Great. So I can actually show you how to do it with decimal. If you don't have a scientific calculator, you can say, oh, where's my, what, oh, yeah, yeah, I want to get the calculator up here. So you can do, where's the calculator? Here is, this is a square root. No, this is the square root. I want to, do they have the, I don't think they have the nth root, so maybe I'll just use this one. So it would be, I need 1/5, right? 1/5. I wanted to do fourth root. So you would say this to the power, no, that's really 1. 1/5 to the power, you do up arrow and then to the power 1/4. That is the fourth root to the power 1/4. 0.6687. If you have a scientific calculator, so B equal to 0.6687. So the equation would be Y equal to, oh, I have to find A also, right? I haven't do A. So put it back here. A would be, I'm lacking of space. 5 times 0.6687 square. So I can go back to my calculator and then I square this number. Let's square it. So is it a multiply by 2 or square? I'm not sure. Do the up arrow and then 2. Okay, 4472. That's A. Okay, A equal to, oh, okay, 4472 times 5 times 5. 2.2361. So my Y would be 2.2361 to the power, and then base 0.6687 to the power X. You can also do those 1/5 things also. Okay. Example 4. In a certain wildfire refuge, 80 deers were introduced to it, and the population is growing exponentially at 14% per year. So they're talking about a constant percentage of increase. Okay, percentage. So, but this is not B. So R, change it to a decimal, 0.14. And that means growing means add, right? 1 plus 0.14 is B, right? So I can imagine, write the equation for both deer population. So the first would be start off with how many? 80. So this is A. 80, and then B is not 0.14 but 1.14. You always just add 1 for the B. X, right? Or T. Let's do T. So the second one would be what? The second one, wildlife, they introduced 92 deer, so you do 92, but they're growing at 11%. 11% is 0.11, right? Change to the decimal. So B is 1 plus 0.11, that equal to 1.11. 1.11 to the power t. So they have different a, b, but both are growing. So if the growth continue, what would be the number of deer at year 2? So we would say plug in t equal to 2 and t equal to 20. So for the first one, when t equal to 2, the y would equal to what? 80, 1.14 square, which is 104, is it? 80 times 1.14 square, 104. If I round to the whole number, and at t equal to 20, so you put 20, y is equal to 1099. So when for the second one, we use 92 1.11. So p equal to y equal to 92 1.11 square. 92 times 1.11 square. So 113 when t equal to 20. So this is a more than 104, right? Because they start off with more. So when t equal to 20, what happened? So you'll be 92 times 1.11 to the power 20. That would be 7041. It's lagging, right? It's falling behind. So in the beginning, the first one has 80, but because the rate, the growth rate is 14% instead of 11%, it's getting more after a few years. Which rabbit will have more population in the long run? So you can see, I think it's the first one, right? Although they start off smaller because they grow faster, and starting from, you can see at t equal to 20 is already growing more, and it would be more and more the first. What other factor will influence the growth? So will this growth continue infinitely, that they would have infinite number of deer? Of course not. It would be based on space, right? It's based on water, food, pollution, right? So all these could decrease, and weather also, right? Sometimes, well, it's related to food and these are related to that. So if there is not enough space to accommodate them, they will not grow indefinitely. And there is another model called the logistic model that can model things that doesn't grow exponentially. So this, I'm going to stop here and then do the other function or other example that would write an exponential function given some information.